Chapter 5. The universe expands. Einstein smacks the Frenchman. The Frenchman smacks back. The observations had revealed what the universe was doing. They still could not explain why. That answer would not come from another telescope. It would come from mathematics. How could mathematics explain something the world's greatest telescope couldn't? At first glance, Georges Lemaître seemed an unlikely revolutionary, a Belgian mathematician, a physicist, and a Catholic priest. To many people, those callings appeared impossible to reconcile. Science sought answers through observation and experiment. Religion explored questions of meaning and faith. Georges Lemaître saw no contradiction. Each asked different questions. Each searched for truth. My name is Georges Lemaître. Unlike the remarkable observers who came before me, I spent little time beneath the night sky. My observatory was a chalkboard. The clues had already been gathered. Henrietta Leavitt had given humanity a ruler. Edwin Hubble had revealed that the Milky Way was only one galaxy among countless others. Vesto Slipher had shown that those galaxies were moving. Milton Humason had demonstrated that their motion followed a pattern. Each discovery answered a question. Together, they revealed a mystery. Why should the most distant galaxies appear to move away the fastest? Albert Einstein had already given humanity one of the greatest scientific achievements in history. His general theory of relativity. Most physicists saw it as a new theory of gravity. I believed it described something even deeper, the geometry of the universe itself. Like many physicists of his time, Einstein believed the universe was static, unchanging, eternal. Yet as I studied his equations, I found something remarkable. They did not insist upon a motionless universe. Quite the opposite. They seemed to describe a universe that could change, a universe that could grow or shrink. So I asked a simple question. If the observations were correct, and Einstein's equations were correct, what happened when they were brought together? I began to write. Patiently, I worked through the mathematics, line by line, equation by equation. As the calculations unfolded, a remarkable picture began to emerge. The observations and the equations were telling exactly the same story. The galaxies were not moving away because they were flying through empty space. The space between them was changing. The universe was not simply filled with galaxies. The universe itself was evolving. At first, the conclusion seemed almost impossible to accept, yet every step of the mathematics led to the same place. Then I looked back at the observations. Henrietta's ruler, Hubble's galaxies, Slipher's redshifts, Humason's painstaking evidence. For the first time, they all pointed toward a single explanation. The galaxies were not racing away from a special place in the universe. They were being carried apart because space itself was expanding. Imagine drawing tiny dots across the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. No dot is the center of the expansion. The surface itself is growing. The universe behaves in much the same way. The galaxies are not moving away because we occupy a special place. Every observer in every galaxy would see the same expanding universe. Everything suddenly made sense. If space is larger today, then yesterday it must have been smaller. Earlier still, smaller again. As I followed the mathematics backward through time, the conclusion became unavoidable. The universe had once been smaller, hotter, denser. Not because anyone imagined it, not because anyone wished it to be so, but because the mathematics and the observations left no other possibility. When I published my solution in 1927, few people noticed. Among those who did was Albert Einstein. He listened carefully, then he delivered his verdict. Your calculations are correct, but your physics is abominable. For a time, the world's greatest physicist rejected my conclusion, yet the mathematics remained unchanged. The observations continued to accumulate. Year after year, the evidence grew stronger. Eventually, Einstein reconsidered. After hearing me present my work once again, he rose before the audience and declared, "This is the most beautiful and satisfactory explanation of creation to which I have ever listened." The mathematics had spoken. The observations had agreed. Together, they had revealed one of the greatest discoveries in the history of science. The universe was expanding. But the mathematics had one more story to tell. If the universe is larger today, then yesterday it must have been smaller, earlier still, smaller again. Run the equations backward. and the conclusion becomes unavoidable. The universe was once hotter, denser, smaller. Everything, every galaxy, every star, every atom must once have existed in an unimaginably compact state. It was an extraordinary conclusion, one that would later become known as the Big Bang Theory.